In this recording, we are going to be solving the equation on the screen here, and I have a little bit of color coordinating set up for us to kind of help us out. So first thing we want to do is recognize that this is in fact a rational equation. The way we solve rational equations is we are going to be clearing out our denominators by multiplying both sides of the equation. Now, again, I want to reinforce that we are multiplying both sides, meaning we have two sides of the equation, meaning it has to be an equation. When you have rational expressions which don't have equal signs, you are not going to be clearing out your denominators. That is not happening, okay? You have to find a common denominator, you can bring it together, but you can't randomly multiply an expression by something, but we can multiply both sides of an equation by something. So my least common denominator we would like to find, but you can't do that until you, step 2, factor all denominators. So I already set this one up, and this one is the only one that isn't prime already. We have a difference of 2 squares. We have an x plus 2 and an x minus 2. Once you have all your denominators factored, step 2, you could also write down any of your restrictions. So I'm going to take a moment to do just that. Restrictions are values of x that will make your denominator or denominators undefined in your original equation. So looking at my original equation over here, I see that x is not going to be allowed to equal 2, and x is also not allowed to equal negative 2. If your denominator looks weird in any way, but maybe it's some ax plus b in your denominator, in order to find out what would make it equal 0, I know this might sound crazy, but you set it equal to 0, and then you isolate x. You would, whatever that b value is, you bring it to the other side. If it was negative, it becomes positive. If it's positive, it's negative. And then you divide by whatever that a value is. Maybe it's just a negative. Maybe it's a 2. Doesn't matter. So that will tell you what will make that expression on the left side of that equal sign, what will make it value be 0. And then you just basically say, all right, so then x can't be whatever that is. Got it? Got it. All right, next step is multiplying both sides. And I'm doing this with one jumbo parenthesis, but multiplying both sides by the least common denominator, which is x minus 2, x plus 2. All right, so hopefully the color coding will help a little bit, and hopefully it doesn't make things worse. I'm just gonna see if I could turn it a little brighter. I guess not. So let's see what happens here. Now, this I'm gonna call, I guess, orange, and that one's pink. So orange and yellow multiply into the green over orange. So what happens? Well, we don't need to write out all the denominator stuff. We can kind of just get right to the point. Orange, yellow, green over orange. Oranges reduce out, and then we just have the green, x, times the yellow, x plus 2, plus orange, yellow times purple over orange and yellow. Again, what we're going to see is the orange and yellow actually both reduce this time, and we're only left with purple equals orange, yellow times blue over yellow. And the yellows reduce, and then you're only left with the blue, which you must put parentheses around, times the orange, x minus 2. All numerators and denominators have implied parentheses around them. So over here, sorry, it's a little smudgy, that is the x plus 2. Sometimes you have the same expressions in a problem, but in other places. So I just don't want us to think that they are the same thing. So this is that x minus 2 that was over there. And then the green, blue, and the purple, which were the numerators, they are not supposed to go away. Going over problems in class, I have noticed that people accidentally ignore the numerator totally by mistake. Like, it seems like you guys know you're supposed to obviously include it, but you're kind of a little preoccupied about, you know, what got crossed out and what is staying behind, that you accidentally neglect your numerator, right? So you definitely want to be careful with that. Now, what kind of equation is this? We now have a polynomial equation. So step 1, recognize it's a rational equation. Step 2, factor all denominators. Step 3, state any restrictions on your variables. Step 4, multiply both sides of the equation by the least common denominator. Now, recognize that you have a polynomial equation and take that polynomial equation and solve it like we've done this whole course, right? So x times x plus 2, we have x squared plus 2x. There's this x right over there. Sorry, it's a little slanted, not lined up right. This, please use FOIL or distribution, whatever you want to call it, but x times x is x squared minus 2x and then plus 3x. Negative 2 plus 3 is positive 1x minus 6. Now, how do we solve a polynomial equation? We need to remember that, okay? You are expected to retain the things you learned previously. Well, we are going to do a couple things here. I'm going to combine like terms. I'm going to also be trying to get everything on the left side because when you solve a polynomial equation, you want to get it equal to 0, factor, and solve using zero product property, unless it's linear, and then you could just isolate the x because you can't factor linear as much as just like a constant of some sort, but a linear factor is already prime, so no need to go crazy with that. All right, these two are done. If I subtract this x squared, well, whoopsie whoopsie, no more x squared. That makes it a linear equation, all right? So these two are combined. 3x equals x minus 6. Sorry, it's written a little nuts. 3x equals x minus 6. Rewrote it. Subtract x to this side. That is not 3, you weirdos. Like what? Why do you guys do that? I don't know. I didn't show you that. None of your teachers ever showed you that. You made that up. Okay? 3 bananas minus 1 banana. 2 bananas. Just always use bananas, guys. So you have 2x is negative 6. And lastly, we divide by 2 and we get x equals negative 3. Wonderful. Fantastic. Now, double check your restrictions. Was 3 or negative 3 rather allowed? It was. So solution, all is said and done, is x equals negative 3. And there we have it. There's my solution. Here are my restrictions. I circled my answers. My work is pretty legible. This is a little messy, sorry. But this is what your work should more or less look like. So to see other examples, just go to the playlist, or you could do the next one in the video. The link should pop up on the screen. I hope this was helpful. If you feel like you are getting smarter every second, give the video a thumbs up. If you feel like you have stayed the same or you are getting worse, put a thumbs down. My feelings won't get hurt. It'll just let me know you need more from me. All right. You'll see me in the next video. Adios.